today we are going to do the same thing like yesterday, just that today we are going to find particular solution. Yesterday what we did is we find general solution for a given equation. So this is from example 10.8 from your textbook. We see that this equation we have to use FEMC to solve because we cannot separate y from x, and so we will use FEMC to solve this one, and then we will sub in y is 2, x is pi over 2 to get a particular solution. Okay, so let's use FEMC. So the first step means FEMC is f. F means we have to free dy dx, so we see our equation, our dy dx is already free, and besides that we also have to put our equation in the form of dy dx plus a function of x, y equals to another function of x. So here I just separate y from the 1 over x. Okay, to make it easier. Next part is E, FEMC E. What is E? E is the integrating factor. So now we find our integrating factor. Integrating factor is equals to e to the power of the integral of whatever it is that is beside y. Here I have 1 over x. So now I calculate this one. It is e ln x, which is equals to x. I integrate 1 over x is ln x, e and ln cancel, so got x. Our integrating factor is x. Next is m. What is m? Is we multiply this equation just before we calculate our integrating factor with the integrating factor x. So now it becomes dy dx times x plus 1 over x y times x equals to cos x times x, which is x cos x. So this one can cancel, therefore our equation is dy dx x plus y equals to x cos x. Okay, FEM. Next is C. So what is C? C is combine the left hand side of the equation, which is this one. So to combine this, just put d dx and then put y and then put the integrating factor equals to x cos x. So if we try to check, we differentiate yx, we will get back ni atas ni. Y stay, x differentiate is 1, x stay, y differentiate is dy dx. Done. Last step is we integrate. Integrate what? How to integrate? First put yx and then put dx to the right side. So x cos x dx. So like that. Okay. So integrate x cos x, we have to use by parts. So I will let u to be x and then v prime to be cos x. So my u prime differentiate x is 1. My v integrate cos is sine x. So my equation now becomes yx equals to, integration by part is x times sine x, u times v minus with the integral of u prime v, which is sine x dx. Okay, next step is we calculate the integral of sine x. X sine x. Integral of sine is negative cos. This one got negative, so it become plus cos x plus c. Okay, so now we get until this part is we are going to put our boundary condition. Y is 2, x pi over 2 into our equation. So y is 2, so put 2, x is pi over 2 equals to pi over 2, x is pi over 2 sine pi over 2 plus cos pi over 2 plus c. Okay, so now we calculate, this one cancel, it is now pi equals to sine pi over 2 is 1, so this part is 1, so tinggal pi over 2 plus cos pi over 2 is 0 and then plus c. Therefore c is equals to pi minus pi over 2, which is equals to pi over 2. So c is pi over 2. Next is we sub back our c into our equation. So it becomes yx equals to x sine x plus cos x plus pi over 2. So we can make this more beautiful one more time, which is we can just divide everything by x because we want to make y the subject. So y is divide everything by x, so this one becomes sine x plus cos x over x plus pi over 2x. So now we are done.